Before we go on to the next task, which will be converting the amount of a formula that we have from a mass in grams to the number of moles we have, or from moles to how many grams we have, we first have to talk about something called conversion factors. It seems big and scary, but it's really pretty easy. So let's look at what those would be. At this point in your school careers, everybody has done a word problem in math along the lines of how many seconds are in an hour. Well, if we start with that idea, here are some conversion factors that we know of, and they start with equivalence statements, okay? So if 1 day equals 24 hours, then we could substitute in days or 1 day for 24 hours, or 24 hours for 1 day in a problem if we needed it. We could also do 1 minute is equal to 60 seconds. And again, because those two things are equal to each other, we could substitute one in place of the other. And the way that looks is this. And let's take this guy right here. If 1 minute is equal to 60 seconds, then we can use a conversion factor that says 1 minute over 60 seconds, or 60 seconds over 1 minute. You're very, very tempted to think of these as fractions, and in a tiny way they are, but they're really conversion factors, right? So how we use those? Well, the example is this. Since we've got this equivalent statement that 1 minute is equal to 60 seconds, it doesn't matter if minutes are on the top or they're on the bottom, because 60 seconds is the same thing as a minute, and 1 minute is the same as 60 seconds. And if we were to reduce them, they would reduce to 1. They're the same thing. We use them so that we can convert between units. Okay? So if my question was, convert 23,000 seconds to minutes. We know that we have 23,000 seconds, and we would need to multiply that by some conversion factor that gave us seconds on the bottom so that we could cross those out, and we need minutes on the top. Well, we have a conversion factor that takes into account minutes and seconds, and that is what we did right here. Well, we need this one because minutes are on the top in our problem, right? So we know we would have 1, and we would put the 60 here, and then we would solve it out. 23,000 times 1, then divided by 60. And we would come up with something along the lines of 383 minutes and some change. But I could have easily said, if we have 5 minutes, convert that to seconds, in which case we're still using the same idea of the conversion factor, but this time we need minutes on the bottom and seconds on the top. So we would be using this first conversion factor. 60 seconds are on the top and 1 minute is on the bottom. And again, the point of the conversion factor is the top and the bottom, the numerator and denominator, are equal to each other. So it's a fraction, in quotation marks, that equals 1, the purpose of which is for us to cross off units to get to the correct unit. Now, how does that come into play for moles to grams and grams to moles? Well, you've been calculating grams, molar mass of a substance. And our equivalent statement here is that if I have 1 mole of a substance, that is equal to its mass in grams, or molar mass, right? So if I'm given the moles of a substance, that is equal to its mass in grams, 1 mole. So we have 2 conversion statements that we can make based on this idea of 1 mole being equal to the mass in grams of the substance. It's no different than 1 minute being 60 seconds. Those two factors are 1 mole of the substance over its mass, moles per gram, or grams per mole, right? This is just molar mass. So how do we use that to go back and forth? Well, the first thing that we have to do is to calculate molar mass. Okay? And then use a conversion factor. We're going to use one of those where we substitute in our mass. So let's zoom in and see how this works. We're going back to good old molar mass. We have 8 grams of NaOH. First things we have to do is calculate the molar mass. So we do that by identifying the elements. We count how many we have of each, and in this we have 1 of each. We get the mass of each. You're looking at your periodic table to figure this out. Right? These are all in grams, and then we just simply add them together to get the molar mass. So the molar mass of NaOH is 40 grams per mole. I have 8 grams of it. How do I know how many moles? What I want to know, since I'm given grams, is how many moles, because the worksheet says convert each compound to moles if we're given grams and to grams if given moles. All right, so I have grams, 8 grams, NaOH. Step 2 in my process here says use a conversion factor. So I know I'm going to multiply by a number where I'm going to have grams on the top and moles on the bottom, because I'm looking for moles, so those go on the top. It's 1 mole. It's always 1 mole, and that 1 mole equals, in this problem, 40 grams in the mole. So now I can simply cross off my grams, multiply 8 times 1, and then divide by 40, and I'm going to come up with 0.2 moles of NaOH. Let's try one where we go the other way. Here we have 3.5 moles of H2O. So I'm going to try to get this to grams. Step 1, calculate molar mass. So H and O, I have 2 hydrogens with a mass of 1 to be 2 grams. I have 1 oxygen with a mass of 16. Remember, I got it off my periodic table. For 18 grams per mole. That's the molar mass of our oxygen. So we know that 1 mole of H2O is equal to 18 grams. So now I can set up my problem. I have 3.5 moles of H2O. I need to multiply that by something that gives me grams on the top and moles on the bottom. 1 mole is equal to 18 grams for water. So I simply multiply 3.5 times 18, divide by 1, and I would have 63 grams of H2O. Now it's your turn.